In this brief lecture, I'd like to talk about the relationship between the existential and universal quantifier a little bit more. So the first thing that I want to noting is that universal quantifier is equivalent to the negation of the existential quantifier followed by another negation sign. So this sequent, for instance, is a valid sequent. And what it says is that everything is f is equivalent to there is no thing that is a non-f. I think it's actually fairly apparent that this equivalence does in fact hold, but in your homework you will have the opportunity to prove that this sequent is valid. And once you've proven that this sequent is valid, it's pretty easy to see that other sorts of equivalencies hold. So, for example, it also turns out to be the case that all f's are g's is equivalent to the claim that there is no thing such that it is not the case that if it is an f, then it is a g. Proving that this equivalence holds, proving this sequent would be basically a straightforward repetition of the way in which one proves that the first sequent at the top of the slide is valid. So in your homework, I will ask you to prove the first sequent, but I won't ask you to prove the second sequent. The proofs are virtually identical. I will, however, ask you to prove this bottom sequent. This bottom sequent also tells us something interesting about the relationship between the universal and existential quantifier. What this bottom sequent tells us is that all f's are g's is equivalent to the claim there is no thing that is an f but not a g. Another way to put this is that the claim that all f's are g's is equivalent to the claim that there are no counterexamples to the universal generalization all f's are g's. That is, there are no examples of things that are f's but not g's. So this last equivalency fits nicely with what we discussed in our previous lecture concerning vacuously true universal generalizations. This last sequent tells us that it is both necessary and sufficient for a universal generalization to be true that there be no counterexamples to it. Okay, moving on. So I also want to point out that the existential quantifier is equivalent to the negation of the universal quantifier followed by a negation sign. So, for example, this sequent up here at the top of the slide is valid, and what it says is that something is f is equivalent to it is not the case that everything is not f. I think a little bit of reflection shows that it is apparent that this equivalency does in fact hold, but in your homework you will have the opportunity to prove that it holds. Okay, once you've proven that this first equivalency holds, it is easy to prove that other equivalencies hold. So, for example, it would be easy to prove that this second sequent is valid. The proof that this second sequent is valid would proceed in exactly the same way that the proof that the first sequent is valid does. So in your homework, I will only ask you to prove that the first sequent is valid. What this second sequent says, though, is that some f's or g's is equivalent to it is not the case that nothing is both f and g. Okay, one more equivalency. So what this bottom sequence says is some f's are g's is equivalent to it is not the case that all f's are non-g's. I think this bottom sequent also tells us something interesting about the relationship between the existential and universal quantifier. And in your homework assignment, you will have the opportunity to prove that this is, in fact, the case. Okay, so that completes this brief lecture. I will go ahead and leave it to you now to prove that various of these sequences are in fact valid in your homework assignment.